Children, today I'm going to talk about the exercise 7.7, which talks about maxima and minima, and especially the local maxima and minima. And the approach is going to be the derivative test. That is, first I'm going to calculate the first derivative, followed by equating it to 0, and then calculating the values of the variable and putting it in f double dash x, and then deciding upon whether it's a maximum or the minimum value. So the first question for today is, I have taken question number first part, which says 2x cube minus 21x square plus 36x minus 20. So I'm going to first differentiate, that is f dash x, which comes out to be 6x square minus 42x plus 36. And then when I put it equal to 0, I get 6 times of x square minus 7x plus 6 coming out to be 0, which gives me the values of x's as 6 and 1 on simplification. Now these are the 2 points where I have to study my maxima minima. So I'm going to get f double dash now at these points. So f double dash x comes out to be 12x minus 42, and when I am substituting x is equal to 6, I get my value as 30, which is greater than 0, and that tells me that this is the minimum point. Similarly, when I substitute for x as 1 in f double dash x, I get my answer as minus 30, which is less than 0. Therefore, this defines the maximum point. So now the functional value at the point 1 I am going to calculate, as well as at 6, because 1 and 6 have been decided as the maximum and the minimum points respectively. So functional value at 1 comes out to be minus 3, and at 6 comes out to be minus 128. So therefore the maximum value of fx at 1 is going to be minus 3, and minimum value of fx at 6 is going to be minus 128. Now let's see the next question. Now next question says, question number 3, 7th part, which talks about again the local maxima and the minima if it exists, and then you have to find the values also correspondingly. And the function has been given to me as x by 2 plus 2 by x, with x being greater than 0. Now you should understand that why x has been given to you as 0 greater than, because if it is 0 then the function becomes undefined. Now let's calculate the f dash x. When I calculate that, I get half minus 2 by x square. Now again, putting f dash x as equal to 0, I get the two values of x's as plus 2 and minus 2. But I have been told in the question that x has to be greater than 0, so therefore I take x is equal to 2. Next step is to calculate f double dash x, which comes out to be f 4 times of x to the power of minus 3, which I have obtained from the first line, that is half minus 2 by x square. So therefore now f double dash x at the point 2 comes out to be half, which is greater than 0. And if it is greater than 0, that means it defines my minimum. So therefore there will be a minima at the point x is equal to 2, and minimum value of the function, that is the local minima, will be 2. There is no maxima over here as per the given condition that x is greater. Next question which I am picking up is the last question from that exercise, that is the 4th one. It says that you have to decide the values of a and b when the function is given to you as x cube plus ax square plus bx minus 3, having the local maxima at x is equal to 0 and local minima at x is equal to 1. So therefore now I am calculating f dash x, that comes out to be 3x square plus 2ax plus b. And then the next stage, putting it equal to 0, I get my statement as 3x square plus 2ax plus b equals to 0. Now I was told in the question that it has a local maxima and minima, so therefore I am calculating my f dash 0 by putting it 0, which gives me the answer as b equals to 0. Similarly, when I put f dash 1, calculating f dash at 1, x is equal to 1, putting it equal to 0, I get my statement as 3 plus 2a giving me 0, which implies a is equal to minus 3 by 2. These are the two values of a and b, that is minus 3 by 2 and 0 respectively, when I am taking them to be existing at local minima and maxima there. But now I have to prove it also whether they are really maxima and minima or not. So therefore I have to calculate my f double dash x, which I do it and I get the answer as 6x plus 2a, and when I substitute the value of x, a as minus 3 by 2, I get f double dash x as 6x minus 3. Now again, checking it at those 2 points which I have already defined, f double dash 0, which comes out to be as minus 3 now, which is less than 0, that's negative. Similarly, f double dash 1 comes out to be 3, which is greater than 0. That means it has been proved that fx has local maxima at x equals to 0 and local minima at x is equal to 1, because it satisfies the condition of f double dash x being negative for maxima and being positive for minima respectively.